Good afternoon. Today we'll see Shanon Fano encoding. Let me share the screen with you. Okay. Today we'll work out this problem. Given the messages x1, x2, x3, x4, x5 and x6 with respective probabilities 0.4, 0.2, 0.2, 0.1, 0.07, 0.03. Construct a binary code by applying Shanon-Fano encoding procedure. Determine code efficiency and redundancy of the code. So in Shanon-Fano coding, we have to divide the given symbols or messages into two groups. Since it's a binary coding, we have to divide it into two groups. To one group, we have to assign 1, and to the other group, we have to assign zeros. And the criteria for the group division will be summation of the probabilities. The summation of the probabilities of the two groups should be more or less equal. So the first step will be to arrange the given messages and their probabilities in the given order. Unlike Huffman code, here you have to arrange the symbols and the probabilities in the order that they are given. So let us form a table. And there are 6 message symbols, and you'll have 6 probabilities. So just take 2 columns. Two columns and 7 rows. 2, 3, 4, 5, 7. Okay. This gives the length of the okay. So this will be symbols, and this will be the probabilities. So first symbol will be x1, small x1, x1, it comes to capital, it will be x2, x3, x4, x5, and x6. And the probabilities assigned will be 0.4, 0.2, 0.2, 0.1, 0.07, and 0.03. Okay, so the first step will be to divide this into two groups. And the condition for dividing this will be the sum of the probabilities of the two groups should be more or less equal. So I have 1.4 here, and other values are small. So let me take the sum of all these smaller values. So this will be 0.2 plus 0.2, 0.4 plus 0.1 will be 0.5, and these two will be 0.1. So this will be 0.6. So this will be, or let me see it like this. If I combine these two, 0.4 and 0.2, it will be 0.6 here, and here it will be 0.4. So let me choose the first group with probability 0.4 and the second group consisting of all these elements with the probability 0.6. Okay, so let me divide this into two groups. Let me insert one column. Insert columns to the right. So this will be one group. Let me shade this one. Okay. So this will be my first group and this will be my second group. So the second group, let me shade with another one color so that it will be easier to identify. Okay, this will be my second group color. So to the first group, I am assigning 0. Sorry, first group I am assigning 1 and to the second group I am assigning zeros. 0, 0, 0 and 0. Okay. So this will be my first step. Let me insert another one column to the right. This will be my step 1. This is going to be my step 2. So now you can see this one is over because there's a single value. There was a single value in this group and it is assigned a code value 1. So now we are no more going to bother about this. Now this second group, group 2, you have to again divide into 2. So again you have to take the sum of the probabilities of the possible group division. So let me take this as 0.2 and if I take the remaining, it will be 0.2, 0.3 and 0.4. Okay, so here again, the division will be 0.2 and 0.4. If you take the first two, it will be 0.4 and 0.2. So anyway, let me divide it as 0.2 and 0.4. Okay, so now this is my one group. I'll change the color here. Okay, so now this is my one group and this I'll put it as white because that is over. And this is a different color. Okay. Now here, this is my first group and this is my second group. Okay. So the first group, I am again assigning 1 and to the second group, I am again assigning zeros. So this one, it's going to be repeated like this. Let me from the next column to the right. Remove the shading here. Okay. Now again, this group's coding is over. Again, I have to divide this part. So here the probability will be 0.2 here. And if I sum up all these things, it will come to 0.2. So I can take this as one group. I'll put 1 here. And this remaining will be the second group. I'll put zeros. Okay. And now I think you'll understand there's no need to color. So this is the first group. This is the second group. Again, I have to divide the second group again. I'll insert one more column to the right. And this is over here because only one member was there in this group. And here there are 3 members. If I divide the probabilities, this will be 0.1 and these two combined will be 0.1. So this can be one group. I'll put 1 here. This can be the next group. I'll put 0 and 0 over here. Okay. Now you have one more division for this group consisting of two numbers. So here, since there are only two message symbols, you can assign 1 to one group and 0 to the next group. So this will be 1 here and 0 here. Okay, so that is all with this coding part. This will be step 3. This will be step 4. This will be step 5. Right. Now you can assign one more column to the right and add the code words. So this will be the code word here. So for writing the code word, you have to just put in the values that you have assigned in each step. So for x1, the value code word will be 1. For x2, the code word will be 0, 1. For x3, the code word will be 0, 0, 1. For x4, the code word will be 0, 0, 0, 1. For x5, it will be 0, 0, 0, 0, 1. For x6, it will be 0, 0, 0, 0, 0. 5 zeros. You can have one more column here to assign the length of the code words. Length of the code word. Let us assign it as L suffix I. Li. Okay. So here the length of the code word is going to be 1, since there is only one bit being assigned to the message symbol x1. For x2, it is going to be 2. x3, it is going to be 3. x4, it is going to be 4. x5, it is going to be 5. x6 also, it is going to be 5. Length of the code word. Okay. So now you have formed the code and you have found the length of each of the code words. Now you are also asked to find the code efficiency and redundancy of the code. So for finding the code efficiency is given as H of S by L. H of S is nothing but the entropy of the sources. Efficiency is equal to H of S divided by capital L. And this capital L is the average length of the code word. L is the average length of code word. And it is given as Pi. Pi is nothing but the probability. Pi into Li. So for finding the average length of the code word, you have to take the summation of all these probabilities. That is 0.4 into 1 plus 0.2 into 0.2 plus 0.2 into 0.3 plus 0.1 into 0.4, 1 into 4 plus 0.07 into 5 plus 0.03 into 5. You have to take the summation of all these values and that will give you the average length of the code word. So for this problem, the average length of the code word is given as L is equal to 2.875. Minutes per message symbol. And efficiency, entropy, you have to find by using the formula summation of I equal to 1 to 6 pi log base 2 of 1 by pi. And the value of entropy for this problem will be 2.56 bits per message symbol. And finally, you have to find the efficiency is given by the symbol eta c. Eta will be equal to h of s by L, and the value that you get over here will be 89.04%. Sometimes redundancy will also be asked in the problem, and you'll have to find the redundancy, which is nothing but 1 minus efficiency. So I hope this procedure is clear. Whenever you get a Shanon Fano code, you have to arrange the probabilities in the given order of the source symbols, then divide them into two groups. The criteria for grouping will be the sum of the probabilities. The sum of the probabilities of both the groups should be more or less equal. Then assign 1 to the first group, zeros to the second group, till you reach just 2 members in a group. Then you write the code word, find the length of the code word, and you can answer all the other questions that are asked relating to this code. Thank you.